Good evening, sir. My name is Sechans, Group 1. Our title is Photovoicing Accelerated Educational Content Generation using Multi-Agent Large Vision Models. Basically, from our title, photovoicing means generating visual images in form of a narrative visual story, and accelerated educational content generation means creating learning materials at a very high speed, and multi-agent large vision models refers to the creation to the use of a number of AI agents, basically large vision models which are able to study images or generate images. Keywords are photo voicing, as I explained earlier, large vision models. These are AI agents trained to study visual content, basically images and videos. Visual storytelling, this is a form of generating maybe visual content, basically images and videos. Education content generation, this involves generating learning materials. We have text-to-image synthesis, the study of text-to-image prompts, then narrated learning materials. This is a form of a visual story also. So, these are contents of my presentation. One, we have the introduction, related work problem statement, among others. The introduction. So Uganda faces a major challenge in providing quality education within the low resource and crisis affected settings. And basically, these are Uganda's refugee areas, and the traditional text-heavy teaching methods and the textbooks are ineffective for these children with interrupted schooling and basically different languages. So the paper proposes a solution of leveraging recent advances in artificial intelligence and large vision models. And here we can create accessible visual learning experiences to go beyond the traditional text. Basically, it introduces a photo voicing approach where educators can input curriculum topics and the AI system automatically generates a narrated visual story in the form of images. And basically, the result is a speaking photo. So this is my literature review, and the papers I have visual instruction tuning, where we have Blava, the large language, and the vision assistant, and this basically enables image-guided instruction tuning for multimodal reasoning. It has its limitations. It requires a high internet connection and is a large GPU. We have PALI. It is a large-scale vision language model for multilingual tasks. We have ControlNet. This is for controlled image generation. We have segment anything model. This enables accurate image segmentation. We have the contrastive learning image pre-training, which enables image text alignment, and the quantized row rank adapter. Basically, it is memory efficient, and the copy text to speech for multilingual high quality. Since the project involves cultural settings, following cultural settings, so we shall have multilingual advancement. The problem statements, domain application problem. Basically, Uganda's refugee settlements lack engaging culturally relevant competence-based curriculum aligned materials, and the overcrowded classrooms and text-heavy resources fail the multilingual, often traumatize the learners. This is because these heavy textbooks, and in most cases produced in the Western norms or Western languages, such as English, this is too hard for some learners that come from different cultures and know different languages. The computational problem here is basically generating a coherent culturally accurate visual narratives from educational prompts, and this requires fusing a multi-number of models for controlled image synthesis, preserving character constants, and multilingual audio-visual synchronization. So, research questions are, how can AI-generated photo voicing create an effective culturally relevant educational content? This will be through these objectives. One, to design and implement a photo voicing content generation framework, to develop a complete competence-based curriculum and learning modules using large vision models, to integrate a generative storyboard engine for automated visual sequencing and to optimize rendering and deployment to low power environments. So the research contributions who are able to develop a pipeline for generating culturally relevant educational content in refugee settings. And with this diagram, this is how the product looks like. So the methodology, one, it is a two-phase methodology where we have the cloud-based authoring and the on-device learning. And one, the teacher prompt input in like how to grow maize, it will be broken down into three steps, into multiple steps, not only three multiple steps, by models such as Lava, the large language and vision assistant. It will break them into step one, step two, step three, and an image generating model such as Stable Diffusion will be able to generate images for those steps. Then there is visual generation engine, then the text-to-speech engine, such as Google, it will be able to generate audio messages, maybe explaining those steps in different languages, such as Kiswahili, Luganda, and English. And basically, the phase two, the on-device learning, the system will be embedded on the mobile device through an app bundle. So this is the overall system architecture as earlier, the cloud-based content authoring. And where through the models such as Lava, it is broken down into three steps, and an AI an image generative model such as Stable Diffusion 1.5, it will be able to generate images for the three steps, and then a text-to-speech engine such as Google will be able to generate audio messages explaining the texts that are annotated on the images. So, and it will be compiled as a final product. The description of our data set, we got a data set. Basically, we created our own data set. Since the system is going to be based on the culture, we were unable to get a relevant data set. So we had to create one with 165 comprehensive biology entries for Ugandan, senior to senior for curriculum. It's 100% complete. And that is the EDA results as you see in the photo, in the image. So the keywords basically from our data set, we have oxygen, photosynthesis, plant, carbon dioxide, reproduction, among others. This topic discussions, the topics we have are basically introduction to biology, locomotion, nervous coordination, nutrition, among others. So the output results here, we carried out comprehensive experiments on our models, and we evaluated them. Then we evaluated them, and we evaluated the baseline model and then a fine-tuned model and that of the proposed system and the accuracy. Basically, before fine-tuning, it was 35.2. And after fine-tuning, it was 68. Then the system 91.5 accurate. So then human cultural relevance, before fine-tuning, it was 1.9, 1.8. Then after fine-tuning, it was 3.5. Then the final system, it was 4.6 on a combination of all models. Then we have the memory requirement. We have the performance retention, among others. So we have the explainable AI results and discussions. We carried out comparative analysis of the image generation models for cultural relevance and the baseline stable diffusion before fine-tuning it. It had FID of 26.7 and the fine-tuned one had 32.67, and basically the culture clip was 0.15 and then the fine-tuned one was 0.25. So model selection and deployment, the models we selected Lava 7B, that is the large language and vision assistant on 7 billion parameters for instructional decomposition. We have UniControl.net for culturally consistent image generation. We have the mobile VLM for on-device Q&A and the text-to-speech engine for multilingual narration. We have the quantized low rank adapter, which is 8 dB for full-time fine-tuning. We have the clip, among others. So this snapshot shows the interface of the deployed system. And here is a demonstration of the deployed model. So, yeah, as you see, a topic was input such as introduction to biology, and the model was able to generate, okay, actually it generated various steps, or it broken down the topics into various steps. Then those steps, the generative model created images, and then the text-to-speech engine generated audio from the created annotations of the images. Since each image was annotated, so the text-to-speech converted that text into audio and in different languages. So as you see, so that the conclusion, the AI system successfully generates culture-relevant educational content for refugee learners, demonstrating improved engagement and comprehension. And basically, the limitation, we have device dependency. It requires Android tablets or any device. Okay, the content scope basically currently it covers biology and a few topics, not all. And then power reliance, it requires electricity and teacher training. Future work, also we can add in more subjects. That is the acknowledgement and the references. Thank you.